So thank you very much for coming. Before I start off, how many people here are actually using Erlang, and how many people are kind of just interested in using Erlang? So if you can figure out if you're actually using Erlang in anger. Okay. And if you're thinking of using Erlang, if you've never used it before, you're just interested to find out where it's being used, you can put your hand up. Okay, so that's the majority. So that's good. So the people who know a lot about Erlang, you're going to enjoy this. So the people who
can I ask another question? In addition to that, how many of you are interested in knowing what bet365 are doing? Does that?
Right. Okay. So a bit about me. I'm Dan Macklin. I got promoted, so I'm now head of. Thank you. It was a little while ago. I basically run the R&D team inside of bet365. The remit of the R&D team in bet365 is to basically run a startup within a much larger organisation. So my team, and I have a very small part in its job, is to look at interesting step change technologies, see how they can be applied to the business, find out if there's anything useful about them, and then kind of work a path to adoption. So it's a very exciting job. We get to play with lots of stuff, but we're also very much into building POCs and then transitioning them to practical, real systems. So a bit of background about bet365 now. I missed the memo that said we're not allowed to talk about AutoCAD anymore. But bet365 is a really interesting company, and it's one of these companies that's gone through what you could almost term kind of like hypergrowth, from very humble beginnings in Stoke-on-Trent, in a porter cabin that probably looked a little bit more classy than that one over there. We're about to, in the next couple of weeks, move to our new, very posh, custom-built offices. So from a standing start to £34 billion worth of transactions being processed in about 13 years or so is quite a journey. And really, one of the things that I want to talk about is how we got there as a company, and how Erlang has helped us move to that next level of kind of business growth. And I can't stress enough that the rapid growth of the business creates lots of interesting constraints and lots of interesting problems on a business. And I would like to try to, as we go through the talk, highlight how Erlang has kind of helped in those different areas. So yeah, as well as just to give you an idea of how well the business is going, as well as those new posh offices there, we're also opening another office in Manchester where we're hoping to get another 70 or so developers. So if you are interested in a career at bet365, you can Google bet365 careers, or have a chat with me later.
Do we have to go to Manchester?
We have remote workers as well.
Oh, okay.
So there's lots of opportunities. So first of all, I thought we'd say that we use a lot of Erlang at bet365. We also use a lot of other tools. We have very much a right tool for the right job mentality. So we use Go, Java, .NET, VB.NET. We use a whole range of different technologies. Erlang is mostly using kind of like our middleware kind of systems. So you've got to ask yourself, why? Why did we decide to start using Erlang? And the truth of the matter is that we had lots and lots of suitable problems. Earlier I was talking about the fact that the company has grown absolutely massively, and we got to a stage whereby we had a culture of being very pragmatic about our tools and the way that we did development, and we built systems that scaled to a certain level. And then our customer base started to overrun the scalability of the core systems that we physically actually had. And so we ran into loads of problems with what I tend to call the scale innovation dilemma. And what I mean by that is that as a company, our culture is all about customer excitement, and it's about interaction with our kind of online platform. And so consequently, to drive that engagement with customers, you want to be very fast to market, you want to be able to get systems out the door really quickly, and you want to be able to move at the speed of a startup. However, we basically we're carrying around this really, really big infrastructure that was starting to slow us down. And as I said before, this infrastructure just wasn't scaling for us. So we were looking for kind of like a step change. We were looking for technologies out there that would allow us to keep this culture of innovation going, but also be able to innovate at scale. Now, gambling's a very, very peaky, very, very busy, very, very dynamic kind of industry. And so, you know, for us, one of the key things that we look for in any technology is reliability. You know, with some of the features that we have on our website, you know, people have obviously a very big vested financial interest in the platform being up. We've got platforms like Cash Out, whereby people can close bets out early. If there's any kind of downtime on those different platforms, then you know we can run into all kinds of trouble very quickly. So, in summary, why? Because we had problems with getting things done quickly at scale, and we also had underlying scalability problems with some of the more traditional kind of SQL-based tools that we were using in platforms. So, I've said getting Erlang, we're using it lots, and it's been very successful. But I'll be the first to say that getting Erlang into a large established company is not an easy exercise. And so I'm going to spend a little bit of time going through the different steps that we went through to adopt it. Now, obviously our company is very different from any other company. So I wouldn't 100% advise following our path, but maybe if you're interested in playing with Erlang or interested in adopting Erlang in your company, you might learn something from some of the mistakes, pitfalls, and kind of things that we had. So, what's the first problem with adopting Erlang? Well, the first problem with adopting Erlang, back when we started doing it, was knowing about Erlang. I'd been a committed Javaist for many, many years, and when we started our Erlang journey, I wasn't in the R&D team, and so consequently I never came across it. And so there's one person in our organisation who was who basically kind of started the Erlang buzz going, and that was he was our CTO at the time, or our CEO, Martin Davis. And I think implicitly he'd been looking at the growth of the company, and he was worried that we were going to start running into scalability problems. So Martin is kind of like he's very hands-on CTO. He's very technically savvy. He's very good at spending his hours outside the office and learning new stuff. And he came across Erlang. And I remember at the time I was a team leader working for one of Martin's projects in the Java space. And we started kind of talking about Erlang. And he started talking about Erlang and kind of saying, we really should be looking at this. And I've got to admit, because I was a committed Javist, I've never really heard about it, I kind of sat there and, to be fair, I ignored him for a long period of time. And not in a bad way, but you know what it's like. You've got your day-to-day work to do, you've got, things that need to go out the door, you don't necessarily have the time to look at anything else. And I went, Erlang, that's really good. Thank you. And so I remember I was on a holiday, and it was at Centre Parks, and maybe it shows something about my background. And I was at Centre Parks, and my daughter and my wife decided that it would be a really good idea to make some nest boxes. And so I thought to myself, it's not really my kind of thing. So they went off and made nest boxes. I was nest boxes even. I was alone in the room, so to speak, back in the Woodland Lodge or whatever it is. And I thought, okay, Martin's been sort of, talking about this. I'll go for it. What's the worst that can physically happen? So I did a bit of googling on Erlang, and whoa, I saw this really, really scary stuff. And I kind of took a look at it, and I went, atoms, tuples. I did a bit of Miranda at university, but I spent a lot of time at university quite drunk. And so, I kind of go, this just seems completely alien. Prolog-like syntax. I passed an exam on Prolog once. Oh God, I thought I'd come back to that, and I thought to myself, well, I've invested a couple of hours. No, this is definitely, absolutely not for me. I haven't got a clue what's going on. I'll, just stick to what physically I know. So then Martin decided, and I think we got this response from a lot of people inside of the company. Thought, well, I know what we'll do. We'll create an R&D team. And so if we create an R&D team, then I can officially tell people to actually start looking at this technology. And luckily, I managed to get into the R&D team. Don't know how, since I've been quite dismissive about one of some of the things that Martin had been saying. And our first task when we joined, or when we started the R&D team, where I was an R&D engineer at the time, was basically to start evaluating Erlang. So, first of all, people have got to find Erlang, and the point I was trying to make in that long rambling story out there is it normally takes a very strong, very senior personality, someone who is, willing to go the extra mile to actually even find the platform. Especially, we were pre kind of WhatsApp and stuff like that, and there's a bit more buzz about it. But typically going off and finding it is very difficult. Once you've found Erlang, you've got to go off and convince people to actually try it. So when we created the R&D team, the first thing we did was look at a project to do with our push systems. So our push systems are very interesting. Basically, being an online bookmaker, our biggest markets are in play. And what that means is people don't tend to bet on the full-time outcome of an event anymore. They bet on who's going to score the next goal, who's going to fall over next, who's going to win the next penalty. And in order to do that, we have a trading team who are setting all the odds. And the idea is we need to disseminate that information out to our customers as fast as humanly possible. Because if there's any latency inside of those updates, then by the time the customer receives, I want to bet on that, the market has moved on and the bet is no longer valid. So we've got a really, really big pub subsystem, which historically was written in Java called a publisher. And what we were tasked to do is try and re-implement this in Erlang and physically see how it goes. So convincing people to try it. What Martin did was he basically went through the back door and he basically made a team of specialists to actually who had time and space to try Erlang. Not a lot of companies have that kind of freedom or ability to do that. So we found a suitable project, and we basically decided that what we do is we'd implement it exactly the same as the Java-based system that we had was. We knew what the APIs were. We set about learning Erlang. We spent a lot of time kind of performance tuning it, and eventually, fairly soon, we had a POC that was a lot slower than the Java one. And so, we started, we were a bit upset about it, we started talking to some of the other teams, and they went, well, kind of told you so. But, and again, one of the things the common things perseverance. We persevered, and we learned a lot more about Erlang, and we engaged with Erlang Solutions, and they gave us some specialist help and stuff like that. And eventually we had a system which was about 5 or 6 times faster and more scalable than our Java-based system. And, that was basically because we went through a period of learning, and we learned an awful lot about how to write Erlang systems, and we started looking I'll go into later kind of distributed systems and stuff like that. And so at that point in time, we had this publisher POC. It looked really promising. One of the other things that was really cool about it is that bits of it failed, but the entire thing didn't stop working. And if for a company like us, where availability is really, really important, that kind of led to intriguing stuff, because we're always trading different markets and we're doing different things and we want to move really quickly. And so you imagine the flows of data through the business. It's very hard to manage those flows of data to be correct all the time. And so if you have a system that when it gets some duff data, the entire thing goes bah and just dies horribly, that's not going to be very good. And so what it means is if you're absolutely paranoid about your entire system crashing due to some duff data, you've got to be really slow and careful in absolutely releasing everything from the system. Well, here suddenly, the system where we could get glitches and stuff like that, and yet little bits of a site would fail, little bits would go wrong, but ultimately, the whole thing worked. It kept on working and kept on flowing through. So, once we had built our little POC, we then started going around the company, kind of shouting about it, and kind of going, yeah, it was slightly faster than the Java one. That won us some friends. Made us a couple of enemies as well. No one likes to be told that the thing they've been working on for years and years, there's a better or different way of doing it. Just looking for my notes again. So we liked what we saw. POC worked really well, and so once we had built that, we went to the next level of evolution. So we found Erlang, we'd done a project, we had a core competency of people who were getting au fait with technology and liked it. But in Bet365 world, nothing is any good unless it actually makes it out to production. You know, you can have all the theories, and you can sit there and go, oh, on paper, this thing is absolutely fantastic, but if it doesn't get to production, okay, it's worth for absolutely nothing. Now, this is where sometimes some of the people dynamic starts coming in, because you go through a journey and you think, okay, I've got one person in the company who's interested in Erlang. He struggles to get 5 people in an R&D team interested in Erlang. And then the next stage is that you need to get, well, those 5 people need to maintain those interests. You need to get 10 people involved. You need to get the operations team involved. You need to get absolutely everyone else involved. And you've got a POC, which on paper looks shed loads better than the existing system. Now, part of your mind would say, well, I'll tell you what you do. We'll take that code, whack it into production, and away you go. But one of the things about adopting software is that you need to bring people along with you. And the very worst thing that you can do if you need to bring people along is force something across them. So again, one of the big things that I would say if you're adopting Erlang is you've got to let the teams go on the same journey that you've gone to get to the point where you're actually comfortable with Erlang. And so what we did was, well, we've got this POC, absolutely fantastic, and of course save the company loads of money, but what we're going to do is we're going to let the other teams go for that journey and re-implement it again. And so we then acted kind of like as consultants with some of the ESL people to say, okay, here's our POC. We loved our POC, it was awesome. But the right thing to do was to allow the dev teams to go through that stage of engagement again, to get their hands dirty, to hate Erlang, and then slowly start to love Erlang, to actually learn some of the very subtle things. And I'll try and go through some of the things that I think are very subtle about Erlang, which makes it such a powerful platform later on in the talk. But you know, don't be too hasty in the adoption cycle would be my big piece of advice. If you're in a big company and you need to get other people involved. So about probably 6 to 7 months after our Erlang journey starts, all in the midst of time, so you know, 100% quoting on those timescales, we had our first Erlang publisher-based system out in production. We had a different team who were outside of R&D supporting it and running it. It didn't fall over, everything looked really good. But having one system out in production in a company where we've got, you know, 600 people in technology, so to speak, does not make a sustainable ecosystem. You really need to have multiple tools and systems which are using it. So the next job, once we got our first system out, was, you know, what other projects do we have? You know, what other things could make use of this technology? And what we needed to do is we needed to get enough systems using Erlang to be able to keep our core development team physically actually busy. And so that is the next stage of involvement. So starts off small, gets a little bit more interesting, and you can see it's just like these layers of an onion getting bigger and bigger and bigger. And so the next thing was critical mass, and hopefully I'm going to talk about why it can be difficult to get critical mass when you're using Erlang. So basically, the biggest problem with Erlang is fear of change, fear of failure, fear of doing the wrong thing, and that fear manifests itself in many different ways. A, it looks a bit strange to start with, okay? And if you're in a very development-focused organisation where you've got to stick to timescales, you're suddenly looking at something that doesn't look quite the same as what you're used to. Suddenly, there's a bit of a fear out there. People have fears about their careers, you know. I think personally that the UK job market kind of sucks to a certain extent. You know, it's getting a little bit better, but everyone is obsessed with how many years experience you've got in this technology, or can you do EJBs, or can you do all this kind of stuff. We're not really after the pragmatic problem solver. If you go to jobserve.com and type in Erlang, we can see the odd job every now and again, but you type in .NET or Java or something like that, and you know there's so much more kind of seeming opportunity out there. And so people are scared, oh, okay, if I invest a significant time inside of Erlang, will it actually atrophy my skills? Will I be less marketable? And I would say, well, no, if you're that kind of person, so to speak, and being a pragmatic problem solver, it's far more powerful than 10 years, core J2E or .NET development stuff. So, but we had that inside the company. We had people who had defined their careers by the technologies that they're working in. You're suddenly come along and saying, here's this new thing, you're going to get resistance. And again, you've got to work with people through that. And, Erlang has got to get enough critical mass, both inside an organisation but outside, to kind of alleviate that career-based, you know, what if I lose my job and then I say I've got Erlang on my CV and no one wants to employ me? The other thing is that there needs to be sometimes a cultural change inside of an organisation to adopt Erlang. So you've got the personal level whereby you know, worried about the job, but for Erlang systems, typically, in my experience, really good Erlang systems work across teams, but a lot of teams tend to be very siloed, and so you know, just getting people to write within one team an Erlang-based system is fairly hard. But then you've got to basically be able to make the culture of the organisation change so that the inter-team working between the teams is an awful lot better. And we've had mixed success in that in our kind of Erlang adoption. But you know, there's all these barriers to entry, and you know, make it quite difficult to get going with Erlang. And I'm going to talk about some positive stuff later, by the way. But I just want you to kind of know that it's not a walk in the park, and it's not really straightforward. So, where do we use Erlang now inside of bet365? So we use it in our push systems. So that system, the first one we did in Erlang, which is about the data dissemination of worlds, is still out there. It's still in production. We're in its second release now, and it's really doing the business. We use it for a product called Cash Out. So Cash Out is basically the ability to close out your position early in another language. So what we do is that we kind of settle all of our bets that people placed based on what the current position of the market is. And so say, for example, your team is 5-0 up at half time, you think, well, this is a dead cert. I actually really want to bet on this over here. You can close your bet out early and then kind of repurpose that money. If your team is 10-0 down at half time and you think, oh, well, out of the goodness of our heart, we will give you a small amount of your physical actual money back. Now, Cash Out is a very interesting point because it's embarrassingly parallel. And so what we need to be able to do is transfer the information from various data streams inside the company into a calculation engine, which basically sits there and just churns the maths and settles all the bets at any period in time. Again, it needs to be low latency, but boy, does it need to be reliable. Because if you imagine that you staked £10 on a certain market, and then suddenly the Cash Out system failed, you can imagine the furore and stuff like that you would get on Twitch, because people would actually feel cheated. I was going to close that bet. Oh, well. And some people would take advantage of that situation as well. Yes, I was going to close that bet, and all this kind of stuff. And so that for us was a perfect Erlang system because it was embarrassingly parallel, needed to be really reliable, was really complicated, in terms of the different business logic which was inside there. And so what we wanted to do was build something that was simple. And so one of the other things that I'll hopefully get into later is that with Erlang you can solve some very complicated problems in relatively simple ways. And other solutions that we have which are less complex than Erlang in different technologies have millions of lines of code, and the code for Cash Out ended up being a lot simpler, which goes back to this getting stuff done quickly. So again, I'm probably meandering a bit in this talk, but I'm trying to get this consistent theme of that Erlang is a complicated beast and there's lots of subtle things that make it worth the pain of actually adopting it. And the reduction in complexity and the reliability and the ability to do lots of things in parallel are all part of that. So once we did Cash Out, we then really moved on to a much larger part of the system. So we looked at how we go beyond SQL. So the publishing system and the Cash Out system were kind of like at the periphery. What we wanted to do now was we were having problems with the core, the way that we actually transacted some of our transactions, for want of a better way. So we had a huge SQL database, and that database was running on the most exotic kit you can physically get, and basically we could only run it at 50% CPU. So it went slightly above 50% CPU, the entire thing would fail. We'd have to fail over to the redundant data center, and we'd have 15 minutes of outage. So we then set about this project. Okay, well, we know that the business is growing like this. We know that we've got a scalability problem now. We know that we want to maintain our productivity with regards to developers. How do we re-engineer a lot of our background core processes around Erlang without changing all of the client interfaces to absolutely everything? So, so this was a very interesting use case. And one that took a fair amount of time in R&D. So, how do we go beyond SQL using Erlang? Well, the first thing is that Erlang gave us the confidence to start thinking more about distributed systems. And so one of the things when you start looking at distributed systems from a top level is a thing called the CAP theorem. So the CAP theorem is in the event of something going wrong, the P, the network partition, you can either choose to be consistent or you can be available. Now, with all the stuff that I've just said there, we are very much in that point there. We care a lot about consistency, but we really, really care about availability. And so the first thing that we did when we started looking at the next generation kind of transaction processing infrastructure is that we knew we'd have to start dealing with eventual consistency and distributed systems. We started looking at different databases and we came across React. Now, React, fortuitously, is written in Erlang. And if you start taking a look at some of the source code inside React, you will start seeing algorithms for vector clocks and consistent hashing and all this kind of lovely distributed systems kind of concepts. So we decided, okay, well, we're going to build an Erlang-based system, and we really quite like this React thing. We tested it loads. We could see that it had a whole load of high throughput kind of characteristics and stuff like that. But the really important thing about React is it had tools in it for managing eventual consistency. So if you really want to run at scale, you've got to start getting to the realms of probabilistic computing. Things might not be right all the time, but you need to look at your use cases and work out, okay, for this use case that we're doing now, this can be wrong 1% of the time as long as it consistently fixes itself. So React has this thing called sibling resolution, and basically what it means is that if you have two concurrent updates to something, or you have an update in one data center, an update in another, and there's a network partition, both sides of the transaction can actually go on, but when the two things come back together, when the network partition comes back, it will store both copies of that data. And so then on the next read, it gives you an opportunity to go, oh, something went wrong here. Oh, I've got two siblings, and then you've got this interesting job of how do you merge those two diverged physical data sets. And that kind of got us thinking, and we thought, okay, well, wouldn't it be really good if we could kind of automate that merging process? Because you're writing these systems, they're very complicated in themselves, but dealing with error recovery and inconsistent state is an absolute nightmare. And we basically then moved on to the world of sync-free computing, which is avoiding synchronization. And what I suppose I'm trying to say here is that it's difficult to make systems that run at scale. You need to take this approach whereby you know that things are going to fail all the time, but writing these algorithms that do this merge of states which is divergent from each other is really, really complicated. So the first thing that you need to do when you start looking at systems at this kind of scale level here is understand the application invariants for each use case and see if you can tweak them. See if that's really what the business physically actually wants. You've also got to take a much more bespoke case to writing your software. So you look at your traditional database system, and you've got your foreign key constraints, and you've got your common libraries that do everything in exactly the same way, and all this kind of stuff. Really, if you want to run at absolute scale, sometimes you need to bespoke certain operations, and you need to handcraft certain functions so that you can look for how you would absolutely minimize the amount of synchronization that you're using. And that means that when we look at React, you've got to model your data differently. So if you looked at some of our ways that we model data inside of our system now, I would get fired if I looked at a SQL-based system and modeled my data in that same way. Sometimes when you're looking at some of these things, the craziest things absolutely work, so you've got to really experiment. But the real thing that saved our project was this thing called CRDTs. So I don't know if anyone's come across CRDTs. They're a relatively new thing. They stand for lots of different things, but convergent replicated data types. And so basically, we found that we could model a lot of our use cases as sets. And if you have a set algorithm and the operations that you apply to it are associative, commutative, and idempotent, which are the three characteristics of CRDT, what it means is that you can, via some mathematical magic, when state diverges, you can actually get the state to repair itself again without you having to write custom code to do it. So we ended up kind of building this platform for a lot of our, well, some of our transaction processing systems, whereby we permitted certain things to go wrong, and then when they go wrong, we trusted the CRDT algorithm to actually merge that state back together again. And when I was talking earlier about probabilistic computing, we really looked at the invariants and the different use cases to work out what the timeliness of the different use cases were, so that if something went wrong, like someone did this and then that, we knew that we had a window of time to actually repair that data. But the application developer would not have to write the bespoke code to fix it. And so thereby you've got a way of being very productive, because the developers are writing relatively simple code that conforms to these kind of APIs and uses CRDTs, and basically, you know, you have a system that works within certain timeframes. So if anyone's interested in sync-free computing, and I probably waffled to a certain extent, really look at what this guy's doing, Peter Bayliss, and look at what the EU Sync-Free project are physically doing. And you know, some really interesting stuff on there. And it puts a whole new meaning on what it is to write correct programs. Sometimes I feel really shoddy, you know, talking about some of this stuff, because I will write programs which are actually wrong for periods of time. But I do that for a reason, and I do it because I understand what the use cases are. And you know, my team and I do it because we're able to explain what those use cases are to our people, so to speak, so the business and whatever is comfortable with it. So, you know, I've kind of gone off on one there, but Erlang, you know, what was the common denominator that allowed all that different innovation to happen? Well, it was, in my opinion, it was Erlang. We learnt so much about how to program differently and think differently, because Erlang forces you to think differently, that it opened up our eyes and allowed us to move to that next level of innovation, and allowed us to basically fail and mess lots of things up, because Erlang is a relatively hard thing to do, and so there was the expectation in the company that we could mess up, and so we did mess up. But by messing up loads, we found that we could learn loads and learn really quickly. And you know, when you start getting to these really complicated systems, once they're written in Erlang, you know, there's a level of simplicity in there. Once you get past that boilerplate of trying to understand the Erlang syntax and what's OTP and you know, what's a lightweight process and what's immutability and recursion and all this kind of stuff, these are all barriers to getting into something. If you're going to try and do something really difficult, once you get over that, you suddenly find there's a nice layer of simplicity on the other side. And you know, we found that it makes you think in, you know, kind of different subtle ways about the way that you go about stuff, and you know, what your view on complexity physically actually is. And I think it made me personally and my team more rounded problem solvers. It really started us on this journey to kind of polyglot, I always get that word wrong or whatever, kind of programming, and it gave us the confidence as a team to try lots of other stuff. So given all my waffling, you know, where do I think that Erlang as an ecosystem goes next? And I think really that there is three fundamental problems, and I'm going to recap some of the stuff I went before. First, you know, going and adopting Erlang is definitely a journey. And that journey is made up of a number of different phases that I tried to outline before, progressively getting bigger and bigger. And so the first thing that you need to do is you need to make Erlang easy to find. So the second thing you need to do is that you need to make it easy to adopt. So you need good tutorials, training, tooling, support, etc. And in the longer term, we need more compelling, trusted libraries to support a wide range of integrations that people have confidence in. So making Erlang easy to find. You know, we need to get it on more people's radar. In our organisation, it started with one person, you know, and then when we started looking at it to start with, you know, it was kind of like there was just loads of confusing kind of tutorials and all this kind of stuff that didn't make sense. Things are a lot better now, but things need to get an awful lot better. You know, as a community of the people here who do use Erlang in Angular, we need to shout an awful lot more about our kind of successes, and you know, communicate what the. Maybe I've not done a very good job of it today, because it's a hard thing to kind of explain, but communicate that people need to go on a journey, but that journey is very much worthwhile. You know, we need to write press releases, blogs, case studies, all that kind of stuff. We need to make the adoption journey easier, but maybe not too easy, because if you make it too easy, then you don't get that learning kind of effect. But we need to recognise that it's unlikely that people from a traditional programming language background will grok Erlang straight away. So we need to make sure that the resources there kind of flow really nicely from a basic level to a more intermediate level to an advanced level, so that it can support people through that kind of life cycle, given that they're probably going to be under pressure to deliver whilst they're going through. We were lucky, we had an R&D team, you know, we had not people on our back, so to speak, but you know, I can imagine in different organisations where people are delivering or people are doing this as a side project, you know, that could be really tough, and you need lots of support inside of that. Historically, you know, the tooling is quite poor inside of Erlang. I think it's getting a lot better now, but you know, the people who are working on the tooling are aside from the platform itself, and so you know, you've got people like doing the VBAR project or Erlang MK and stuff like that. You know, it's almost like people ad hoc adding things to the platform to physically actually make it work and cover its tracks. And I think that there needs to be a lot of work in there, and that needs to be robustly supported by kind of someone. There are many really good Erlang libraries out there, but if you're going to adopt something as a bigger company and stuff like that, well, having Bob from, you know, Venezuela or whoever and his friend Mike looking after something doesn't really necessarily fill you with a lot of confidence. So, you know, someone needs to be able to take some, you know, the core, you know, integration libraries, you know, things like, you know, SQL Access and, you know, other stuff like that, and they need to kind of find a way to consistently maintain and support them and make it look like it's not just two people in a shed who are looking after these kind of things. Also, you know, some of the libraries are missing. So as I'll say, you know, kind of SQL support is patchy. And dare I say it, you know, web services, things like SOAP, I know they're not really very cool, but you know, certain organisations will want to use those kind of things and will want to know that, you know, their systems work holistically. And so, you know, libraries, these missing gaps need to be filled in. Maybe this one's a little bit controversial, and so you know, Erlang did this 25 years ago. One of the key things about Erlang is its stability. Okay. And so if you've got a community that's obsessed with stability, they tend to be looking backwards, you know, and looking back over past glories and stuff like that. And so I think, you know, that you know, people need to be in the Erlang community a bit more less risk averse. Let's say more risk averse then, but less risk averse. So, and I also think that in the Erlang community itself, there's been a certain geekiness, as in, hey, I know Erlang, you know, it's hard to get into. But once you get there, it'll be really good. But no, I'm not really going to tell you too much about how to get there, you know, because I personally work, yeah, I could earn a lot of money, you know, so to speak. And so I think that cultural change in our community is slowly but surely changing. But you know, there is still a lot of. We did this 25 years ago in Erlang, but we haven't really developed the tooling to make it easy for everyone to do what we did 25 years ago. You know, really easy. Also, you know, one of the things, you know, we need to look at what the Elixir community is doing, and so they are much less risk averse, and I think that they're doing absolutely fantastic things. And the reason for that is that they're very good at marketing. They've basically sat down and said, okay, we've got all these Ruby on Rails applications. They don't really scale very well. We've got this fantastic, very scalable, very solid platform in Erlang. Why don't we market it to these people? And so they've done lots and lots of work in, you know, making Erlang-based systems look very much like Rails and making it kind of trendy and cool. And they've built out one amazing tooling with kind of Hex and Mix and stuff like that. And they're very enthusiastic. And so if you compare that to some of the Erlang community, sometimes they're a little bit of a breath of fresh air. But that is because they've probably got a narrower field. They know exactly who they're targeting at. So maybe Erlang needs to find that narrower field so it can be a bit more like that. Or maybe it does just need to sit there and say we're supporting a core platform. You know, it needs to be stable. We'll let these people go off and do all this amazing funky stuff and actually leverage it, and maybe you know, you with your stuff as well, your Neuro or NFE and stuff like that. But you know, the community needs to know what it actually physically wants to do, and even needs to let the Elixir people go off and be the front face of Erlang, and expect it's not going to be quite so cool being in the Erlang community, or they need to define their market a bit better, I think. So there's this thing called the Erlang Industrial User Group, which we are a member of, and at the moment these are the people who are trying to look after the Erlang platform. If I'm honest, I think at the moment they are a bit too risk averse, And so, there tends to be kind of like a lot of talking, a lot of trying to gain consensus and stuff like that. They need to kind of move forwards a little bit and get more people involved and move a little bit faster, which, going back to what I said before, if they decide to be a bit more, kind of out there, so to speak, then they need to kind of make a few more things happen. At the moment, it's an industrial user group. I think there's like 10, 20 members or so. There's plans to move it to a foundation. And so one of the things that I would say is that if you're really interested in Erlang, you can join the user group, and once it gets past the critical mass, it'll become more of a kind of foundation, and I think that will be good for it. But the key thing that they need to do is balance stability with the need to innovate and bring on a new generation of programmers like the Elixir people, as they actually are. So what are bet365 doing to help? So we are members of this Erlang industrial user group. We've sponsored a number of developments in Rebar 3 and different things. We are involved in 2 open source projects at the moment, and so none of them are spectacularly funky. One of them is soap integrations. You say, well, why would we want to do that? That seems a bit kind of backward, but integration inside and building holistic systems requires these integration points, and someone's got to do it. So we thought, we'll put in. Despite the fact of my brief dalliance earlier into the world of kind of moving beyond SQL, we still use loads of SQL. And Erlang support for SQL Server and stored procedures and all this kind of stuff, again, not funky stuff, is a bit hit and miss, so we're working on the side of that. So the future of Erlang at bet365, I'm almost finished now, I think is bright. We've got a core competence now, and we've got that snowball effect. We've got enough people using it. We've got critical mass for it to be a long-standing and very important platform inside the business. There are loads and loads of other technologies that we're going to look at and adopt, and as I said before, our move into Erlang has given us much more confidence to be vital for the right job. We've got quite a few high-profile projects, which I can't really talk about, which are in Erlang, which are going to be coming out in the near future. But we'll continue using Erlang whenever it's the right tool for when it's the right thing to do. So hopefully, there in summary, I've hopefully not confused you too much, but I've kind of gone through where Erlang started, how it got going inside the company, how it reached the critical mass, the fact that Erlang's a journey. We're using it for some really quite cool stuff, and it really opened our minds to solving those very cool problems. We kind of talked a little bit about the community and where I think it should actually go, and the future of Erlang in bet365 is bright. So if anyone's got any questions, please fire away.
I think your fear of how many developers are working on a particular project is perhaps unfounded. I think many free and open source projects are actually maintained by very few people individually.
Yeah.
If you take OpenSSL,
yeah.
as far as I know, I think there's not many more than a couple of people
Yeah.
working on that.
Yes.
Hugely.
Yeah. Yeah.
So I think the amount of development that goes into something
Yeah.
is more important than actually the number of people that are working.
Yeah, it's it's that quality of development, and it's that quality of being able to to trust it and trust those developers. But if you're looking at it from a very big company corporate background, you get lots of internal barriers and resistance into we can't do this because, we can't do this because, we can't do this because. And whilst I completely agree with you, sometimes if some of the core libraries in Erlang seem to have that little bit more support behind them, it would have made my life or some other people's life in the corporate environment a little bit easier, and it would have made it, oh, this is a big risk. Well, no, it's not, and a lot of these things are about managing with risk. So whilst I completely agree, it's horses for courses, that I think that some of the core libraries just need that little bit more help in Erlang. But they are actually really good, and it is basically almost a paper exercise because they are very good, they do work. We're using lots of libraries which only have 1-2 people physically actually supporting them. But what I'm saying is from the adoption curve, I had to, my team had to push quite hard to, just trust us, it will be fine. And it's how do you make that journey for people following that a little bit easier? And so it's a political thing.
I also wondered how difficult it was substituting one system for another. Switching over.
I would love to talk about exactly how we did that, and it's quite cool. but I could get in trouble. So,
Really?
yeah.
The camera he's pointing at.
Yeah.
Earlier he was pointing at this gentleman sat on the floor as Mr. Verding. If those at the back of the room cannot see.
But yeah, it was quite an interesting project. But unfortunately, to talk about that, I've got to go into real depth about how a lot of our things work under the hood rather than my superficial jazz hands, so to speak. But all that I would say is doable, you know. Yeah, and we're not really very clever. Well, I'm not. My team are very clever, but I can understand how it works. So, you know, it's definitely doable.
So earlier you mentioned that when you first came up with your prototype, it was slower, and then you did a bunch of work. Are you able to share anything with that, or is that not
Yeah, no, yeah. Basically,
I was interested what kind of things you.
If you're from the background of thread pools and stuff like that, you've got a very definitive thinking as to what concurrent programming physically actually is, and you tend to synchronize absolutely everything. If you can suddenly spin up 100,000 lightweight processes and send messages between stuff, and you know you start thinking in terms of recursion and stuff like that, it's a very different world. So our first publisher looked like there is a thing called Erlang. You know, it looked like Java written in Erlang, and so we were using the same principles, we were using the same methodologies. We maybe rocked the syntax slightly, but we hadn't moved from our comfort zone of sod it, just throw a million processes up and just trust that they'll be there and they'll work, and if they fail, they'll fail independently, and it won't corrupt the memory in another process. And it's part of that journey. That's one of the really subtle things about Erlang. To anyone, I would say, you can read loads about Erlang, you've got to do it, you've got to let it fall over, and then you suddenly go, all those problems I've been solving before, I've been worrying about that. So I've got a problem at the moment, I won't go into too much detail, and even now, you know, talking about how you manage concurrency, you kind of think, okay, so I've got all these web requests coming in, okay, and I'm a bit worried that for every web request I'm going to spin up a process to deal with this, because that's going to be a shed load of process, and we sat there and worried and thought, so we'll just try it. And we're talking about a really busy system here. Doesn't miss a bit, and so it's getting over that mental model of everything that you're used to before, and trying a different approach, and being prepared for people to mock it and say, well, I'm not allowed to swear, but you know, you're really stupid. You're dumb. That will never work. And just going off and doing it and going, well, actually, it seems to be okay, and then not being smug about it. That's the hard thing. And honestly, in terms of adopting Erlang in a company and stuff like that, you know, as techies sometimes, you know, it can be a bit like that. You've got to try and be gracious at the same time and realise, you know, that you've had the space and time to go on a journey, and you've got to respect that other people haven't, and try and get them enthusiastic by not rubbing their face in it to a certain extent. But you can speak at home afterwards.
Can you talk a little bit more about your cache-out system? Whether or not it's request-based, or have you got all the positions calculated all the time? Can you give some stats?
Stats-wise, I've got to admit, for my research and development area, I don't really know what the latest stats are. But basically everything is calculated on every single change in the market. And so consequently we've got, it's almost like our settlement process is running flat out all the time for any market movement. And obviously we've got to calculate that in kind of less than 2 seconds or thereabouts. And you know, given the number of events that we trade and the number of bets that we physically have open at any point in time, that is a massively, embarrassingly parallel problem. But it's one that struck the fear of God in us when our leaders, if you want to call them that, basically came across the idea and said we want to go off and do this. Now I'll be the first to say that for bet365 always proud ourselves about being the first to market on something. We were not the first to market with cash out, and that's one of the reasons why politically inside the company we started kind of thinking, oh, we've got to find a different way of physically actually doing something. So we weren't first to market, but I think that we had, when we did get a product out there, the biggest coverage. And you know, we have the best customer service related with it, and that's because of the fact that a little bits of it fail, the entire thing doesn't fall down, and that's just such a powerful thing. It frees you up from I said you've got to be able to fail. In life, you've got to be able to fail well, but you know, you can set yourself up for a massive failure, you can set yourself up for a little failure, and Erlang allows you to set yourself up for lots of little failures on a production system rather than a boom, so to speak. And so that it's failure and resilience and the ability to parallelize out those calculations, which are not massively complicated, but they're still fairly complicated, over lots and lots of nodes, is the key kind of thing to that system.
Yeah, I use Bet365 quite a lot. Are you going to bring out a similar offering to Bet365?
I don't think I'm not a commercial person, so consequently, what our strategy is and stuff like that, I do not really have a clue. I've not heard anything inside that area, but to be honest, until it gets to a project that we're actually going to develop, I'd be one of the last people to know. So I don't know.
Yeah, you spoke a lot about the journey and about the challenges and the problems, but I would ask a very basic question. Why would you adopt Erlang to begin with? I mean, what's the basic advantage of it over any other programming language?
Basically, from our perspective, with the kind of problems that we have, it allows us to fail well. And what I mean by that, it allows us to fail on projects, it allows us to fail in production, and via those failures, it allows us to learn an awful lot more. And so Bet365 is a company that's very obsessed with knowing how things work and being in complete control of your destiny. And messing up, because if you mess up and you learn from it, then you ultimately become much more powerful. And so I would say that dealing with failure is at the core of what Erlang is, because it used to be run inside of telephone switches, and telephone switches are systems whereby you've got loads of traffic going through them, and in the Ericsson days you would get charged an absolute fortune if that switch was physically actually down. So I would say, out of all the things about Erlang, it makes you think about failure, both from a technical perspective, but from a company cultural perspective in a slightly different way. And that's the main reason why. And if that sounds fluffy, it's because you kind of got to try it to kind of grok why that is such a powerful force for innovation inside of a company to get things done. Feeling that failure just kills so many good ideas and so many things. Erlang allows you to, it's a technical way of failing well, failing in a much more controlled way. We do all our own software. I say all. The lion's share of software we write at Bet365 is our own software. So we write the trading applications, we write the back end, absolutely everything. And you just imagine all that flow of information and all that coordination that needs to happen with regards to data to get information onto a site for then someone to place a bet back again. At any point in that journey, anything can fail at any point in time. Someone can release a new trader tool that has one extra byte at the end of something, and that market fails. In the traditional world where we were in before, one small failure like that about one unrelated system over here could have a tidal wave of catastrophe over here. What we found is that, one market goes down, and still, someone probably rings up and we've got to do a release, but it's just that one little bit. The rest of it keeps on working, and that's an incredibly powerful thing. So if I was to say why, that would be my answer. Failing well. Yeah. Sorry, go ahead.
Hey, you said you used React,
yes.
And after a sort of fair bit of evaluation, how much did you look at, and do you maybe use Amnesia?
We use Amnesia internally inside of one project. We use that more when we're after a system that has consistency. Okay, it's a really good tool. I personally, I'm a chaos kind of guy, so I kind of like eventual consistency. And sync-free computing, but it very much has its place. We were worried about Amnesia, so we started looking at these kind of 2 gig, 4 gig limits, and it can give you the odd weird error message and stuff like that. And again, I was talking earlier about libraries and stuff like that, and active development. Sometimes you worry, okay, well, has it really moved on anything? Is anyone really behind it? But we use it in one production system, which is very important to us, and it's been in production for about 1.5 years, and it's worked really well. The programmers seem to like it. But right tool, right job. If you've got an Erlang system and you want an embedded database inside of your virtual machine, which is focused more on consistency, then that's the lowest hanging fruit. So, and it seems to work all right for us.
That's just because you actually have different requirements on different parts of data.
Yes.
Yeah.
Yeah. So for this system, which is probably in the more kind of absolutely has to be correct kind of use case, then we will use a tool that favours consistency. if we have a use case whereby, you know, we want availability and we go through the business what that use case is and we work out what the probability of something going wrong in that journey is and what the mean time to fix that inconsistency is, and will the customer actually notice inside of that time, then we will use more eventually consistent systems. And even then, but you know, probabilistic computing, you know, it's a, you know, is it right? Kind of. Does that make you really feel good about yourself? Well, it's going to fix itself eventually. When will that be? 99.9% of the time it will be within these bounds, you know. But if you've got a culture of failing well, then, you know, okay, if someone in the business is unhappy about that, then we'll move it to more consistent. But there's trade-offs. The trade-off of consistency is coordination. Coordination slows things down, you know, and so, you know, it's sometimes can be a bit of Hobson's choice. But if you're willing to be a bit more risky, in a good way, not, you know, throw the baby out for the bathwater, we certainly wouldn't calculate your balance in a, you know, completely eventually consistent way, you know, or something key like that. But you know, for the right thing, it can really, you know, make actually the customers much more happy in the longer run, you know, because, you know, they're getting good service and stuff.
You mentioned that you did R&D on React, but do you actually use it in production, or
Yes.
do you develop your own?
Yes, yeah, I said before, we build a lot of stuff. We don't build our own database as such. We've built an interesting middleware tool that sits on top of React that, you know, does certain things for us, but we use React. But to be honest, you know, we really do understand, maybe me not personally, but my team and the developers at bet365 really understand how the core of it works and how the core algorithms. And, you know, going back to what you were saying earlier about open, that's why open source is so powerful, because it's a learning exercise. You know, people get to throw out there and these academic-y kind of things that look really hard on paper and are funny maths and stuff like that. You look at something like, you know, the implementation of React Core. Once you've learned Erlang, you go, oh, that's not really so bad. After all, I can do that. And so, yeah, we use quite a lot of React, and we do find it to be, you know, really good. And that's its key differential in the marketplace. It gives you tools, and the React community have been doing a lot of research in this area. It gives you tools to manage eventual consistency a lot better than a lot of competitors, we believe. Actually, you know, I said Erlang's a hard thing to get into, and then you suddenly have like an epiphany and you get going with it. React's kind of saying, sometimes I feel a bit sorry for the React people, because if, you know, you get Cassandra or MongoDB or something like that, you install it, throw it, whoosh, away it goes. And then, you know, you start, you know, looking at React and you say, well, for every write you've got to read first, and then you've got to check for siblings and stuff, and well, that doesn't feel like productive programming, so to speak. But if you just move those next couple of steps down the adoption chain, you suddenly realise, that's why they're doing that. It's about managing eventual consistency. This allows me to, and then the research moved on to CRDTs a little bit. But we do use React in production, and you know, it's good for us.
So one of the things I was wondering, I've seen a couple of times with solutions developed in Erlang.
Yeah.
The solutions tend to be, I would consider sometimes maybe quite wasteful, because because one of the things in Erlang is you can do it that way.
Yeah.
So you can have as many processes
Yeah.
to. The example with the cash outs, the bets, you were saying that you have all of the prices calculated at any one point in time.
Yeah.
But say you've got the Grand National, and you've got like millions of bets on a particular runner.
Yeah.
The price changes on that selection maybe, I don't know, 100 or 200-300 times.
Yeah.
And then do you not get a massive, enormous ripple effect through the entire structure as the price changes?
Mm-hmm.
And secondly, as probably only about not even 1% of bets, not even that, would actually ever cash out the bet at that price.
Yeah.
It's incredibly wasteful on CPU.
Yeah.
But again, you can. So you can do it. It's the ability to can. So I'm just wondering whether or not if you compare that to a system where you didn't take advantage of that, maybe it would actually run on a lot less hardware.
Yeah. The one thing that I would say is that when you start looking at sync-free computing, you look at things very, very differently. And so if you've got many things which are changing one thing, then you've basically got to put a lock there. And if you look at kind of numeral architectures and computers and cache lines and stuff like that, the overhead of putting that lock in place is actually, you know, is quite high. And if you're looking at a distributed system where you're working over multiple replicas of data and stuff like that, you know, doing distributed locks is even more, you know, costly. And so I'd say life is about balance. There's lots of things in balance, and sometimes some of the systems that we've looked at, as I said before, I get fired. if I did that in kind of SQL, and it looks amazingly wasteful. But you have faith, you build them, you run, the World Cup through it, 10 times speed and something like that, and suddenly you find, actually I'm using less boxes than I was before, and those boxes are using their resources in a much more efficient way than this other system, which is sat there with a massive queue using 2% of CPU, but basically you look at analyse it, and it's basically almost deadlocked, so to speak. So it depends so much on your use case, and it depends on your philosophies with regards to computing. And sometimes we will do it one way, and sometimes we do the other. But what we try to do, and this is another thing about Erlang that I don't know about it, and that's very good for knocking together a POC. And so what we do is that certainly in my world, we like to say, I don't want to hear that I think that this is a good idea. I want to know. So we go off and we do it, and then when we do it and you measure it, then it gives you the confidence to kind of do that. But it's a really good question, and it's a really hard one to answer, because yes, some of the things you do are wasteful, but it might be wasteful in the sense of creating and using lots of resource. But if it reduces your latency, increases your availability, and the customer's happy, then is that a price worth paying? Depends on you. It completely depends on use case. But I can see both sides of the story. I would say that since we adopted Erlang, we are getting far better utilisation of our underlying infrastructure than we used to with other ways of doing it. So we are seeing that we are able to use our kit more effectively. So maybe at a small level it looks really wasteful, but you look at the really, really big picture and you go, actually, it's a bit better. But I don't know what kind of problems you're trying to solve. So sorry.
Was that semaphore? Was that?
Yeah.
Sorry, yes, my question is more related to your R&D team.
Yeah.
Because bet365 is a large organization. Obviously, you will have multiple streams of product development going on at the same time. And how do you proportion your R&D team in that stream? Where does the usefulness of a R&D team come from?
Yeah. Basically, we're given more space and time. Okay, and so that is our key physical advantage. We tend to get involved in kind of step change kind of problems, and so if there's a big problem, like the website crashing, so we'll tend to physically look at that. If there's a whole new product area that someone wants to go into, we'll tend to look at that. We'll evaluate new languages, we'll evaluate new database technologies. I'll be honest, we do kind of sit a little bit outside the dev teams, and handovers, are always difficult. They're always a challenge. Anyone who wants to change anything, you have a bit of grit in the machine sometimes, and it can be quite uncomfortable. But luckily, we've got very strong support from from Martin, who's my boss, and we tend to get work from him and from the development teams. I prefer it when we get work from the development team asking us to help, because if someone's asking for help, you're not necessarily kind of pushing it at them, so to speak. Sometimes if you've got a difficult problem and you've got to push through, and they're the more difficult ones. But we keep ourselves busy, and we look at a wide range of stuff. So the distributed systems, I talked for ages about some of the other stuff we're doing that probably wouldn't be beneficial to my career, but it's one small part of it. We've got a very diverse range of people with different skill sets and stuff like that. Does that answer your question?
Yes, that answers the question. So the next question on top of that is, obviously the tech guys are more coming from a developer's background, who like to see what they do being used in a production environment. And how do you actually get that motivated guys in your R&D team?
That's actually a really good question, because that's one of the biggest problems that we face. Solutions people like to see their solutions being used. You've just got to suck it up.
Are you basically saying that you got lucky with your team?
Yeah, well, I've got a variety of people. One of the guys did a PhD in watching paint dry, so compared to that, this is just,
I think, sorry, one last question.
How pleased were operations people in deploying and managing this, like, I'm sure it was a completely new thing. And what was your experience in managing clusters? Because obviously you distributed Erlang.
Yeah.
What was the experience of managing clustered Erlang?
We don't use that much distributed Erlang. So that's, you know, maybe a weakness, maybe a strength, but a lot of our designs trying to minimise that kind of coupling of systems together. The operations people were initially very scared of it, but you know, we were quite lucky. We didn't do a million things at once. We went nice and slowly. We got one thing out. We proved that. We trained those teams up. A lot of them had been from like a more Windowsy kind of background in our operations, so the whole kind of Linux thing. We ran lots of training courses, seminars, you know, and all this kind of stuff. We tried to build people's confidence inside the technology, and confidence is a really important thing. Did we get it 100% right? Well, there's some problems, and there's some people now still probably a bit wired, you know, probably, yeah. But it was a really big sea change for something, and it's still ongoing. We still have shed loads of other systems which are not using this kind of technology. It's basically just being measured and slow, and understanding the people dimension of change. It's actually sometimes it's a lot harder than the technical aspects of the change. You know, people can be difficult, and you've got to try to work with them or work through that fear of, you know, of change, and oh crikey, if a phone is in one eye, I'm going to be left in the poo, and all this kind of stuff. And we just tried as hard as we could to engage those people, be there for them, allay their fears. But you know, there's been ups and downs in that area. But on the whole, for our React-based systems, you know, we just had a rather big sporting event. It seemed to go a lot more smoothly for us than others have before, and so those people like that. So again, you just got to think a bit long term and deal with a little bit of pain to start with to get a lot of gain later on.
Can I, very quick
Mr.
question.
Verding, would you like to?
No, I'm not going to talk. That's what. How many other different languages and systems are you using together with Erlang? Because, I mean, you said Erlang is not the only system.
Yeah, we use the Microsoft stack. We're looking at Go. We're looking at F#. You know, we do a lot of Java. We've not really gone into Scala too much. We're looking at, for some of our problems, C, OpenCL, OpenMP. You know.
Okay, so it's one of a collection of tools.
Yes. Yeah, very much so. And that's the thing. And it's really cool, but you can't use it for everything.
Yeah.
And you can't do my job.
That's what, yeah. I've got to follow on about that. About the cache out. It seems to be an awful lot of numerical calculations.
Yeah. Yeah.
And one thing Alan's not really that good at is heavy numerical calculations. That's what I was wondering.
Yeah. And going back to the gentleman over there's question about resource, is that the most efficient way of doing it? Well, it's certainly the most efficient way of getting all the data in the right place to perform that calculation.
Okay.
You know, in a reliable way.
Yeah.
Is it the fastest way of actually doing the maths? Maybe not. But, you know, swings, roundabouts, balance.
Yeah.
That may be a future project.
Very quickly, sorry, do you use any ports or NIFs?
We tend to try to avoid them. I think we do use them in a couple of places. Again, what you don't want to do is one NIF to fail, bring your virtual machine kind of down.
Sorry.
I don't think we've got any introductions. Again, for my research kind of thing, loads of stuff happens.
Right, I'll draw things to a close if I may, because Dan has to revert to the luxury or the you may describe it as Stoke-on-Trent. He has to get back to homeland. I'd like to thank you very much. That was a very interesting talk.